Hello and welcome. I will be answering NECO 2018 Chemistry Objective Past Question 20. Calculate the number of moles of a gas if it occupies a volume of 4 dm cube at 10 atm and minus 200 degrees Celsius. So you have this constant R is equal to 0.082 atm dm cube per Kelvin per mole. A 73.00, B 40.00, C 6.68, D 0.56, E 0.15. So from the variables given to us in the question, this is calculation of or involving the ideal gas equation, and the ideal gas equation is given as PV is equal to nRT. Now where P is the pressure, which we have here as 10 atm, pressure in atm, V is the volume in dm cube, which we have here, N is the number of moles, R is our constant, ideal gas constant, and T is the temperature in Kelvin. So our temperature here is in degrees Celsius, so the first thing to do is we'll convert our temperature to Kelvin. So minus 200 degrees Celsius to Kelvin will be plus 273 is equal to 73 Kelvin. So we are looking for number of moles, N, and we are given the other variables. So if you make N the subject of the formula, N is equal to PV over RT. So N is equal to, so we can substitute each value now. Now P, pressure, is 10 atm times V, volume, 4 dm cube, over R, which is our constant, 0.082, times T, which is our temperature in Kelvin, 73 Kelvin. Now this is equal to 6.68 moles. So the number of moles is 6.68 moles. 6.68 is option C. So option C, 6.68, is the number of moles of the gas and the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers.